Hello friends, welcome to Moonshine Chemistry. We were last time learning about chapter which was atomic structure. In this third video we will learn about charge on the electron. Let's get started. Whom had established all-drop experiment? All-drop experiments to determine charge on electron was established by scientist R.A. Millikan. What is the charge of electron? The charge of electron is minus 1.602 to 10 minus 19 coulomb. What is the value of ratio of electrical charge to mass ratio of cathode ray? E upon m 1.758820 10 to 11 charge per kg. As we learned from the last chapter that this ratio of electrical charge to the mass ratio was studied by British scientist J.J. Thomson. This is the same scientist who had designed discharge electrical tube discharge tube experiment. He had studied about the cathode ray, and he is the same person who had discovered electrons, and he had determined this electrical charge to the mass ratio, which is 1.758820 10 to 11 C per kg. Now what is the mass of electron? E upon E by m. E charge is 1.6022 into 10 to minus 19 coulomb upon 1.758820 10 to 11 coulomb per kg. So what will be the mass of electron after this division? 9.1094 10 to minus 31 kg. Now mass of electron is found to be 1 upon 1837 mass of hydrogen atom. Means mass of electron is 1837 times less than hydrogen atom, or smaller than 1837 times smaller than hydrogen atom. We can say that subatomic particle electron was further supported by electricity flow, which is electron through a conductor. Beta particle discovery emitted also proved existence of electron, as beta particle was proved to be the same electrons. Subatomic particles electrons, means electron which is subatomic particle, was further supported by electron flow, which is an electron flow through a conductor. Means through a conductor the electrons was further being proved by the flow of electricity. Now beta particle discovery emitted unstable radioactive nuclei also proved existence of electron, as beta particle was proved to be the same electron. Means electron's existence was also proved by discovering beta particle, which is observed when it is emitted from unstable radioactive nuclei. So the beta particle is also proof that electron does exist. This I can say this question is, I can say that how electron's existence is proved other than cathode ray from discharge tube experiment. So we can ask this question about this answer, that how electron existence is proved other than cathode ray from discharge tube experiments. Means we had learned that electron is being discovered by J.J. Thomson when he was studying cathode ray by designing discharge tube experiment, and by he conducted this experiment. But other than that, if there is any proof that whether electron is existed, so these are the 2 points, that is that a conductor when works, it flow electricity. Okay, so this also supports that electron does exist, and whenever unstable radioactive nuclei, okay, get disintegrate, it emit beta particle, and beta particles is also shows that electron does exist. Now turn to next page. Here, after discovery of electron, we now study about discovery of proton. Now this is an experiment, same like we had learned from discharge tube experiment. The same designs are there. Here high voltage power supply there, low pressure gas are present in these tubes, and there is a cathode, anode, and of course cathode charge is negative, anode is positive. But here is a difference. Now cathode is actually have perforated hole, and some ray just pass through this hole from anode. So we will learn about this experiment, that how did proton was discovered. See, electron is negatively charged particle is ejected from cathode surface and go to positively charged anode. Positively charged particle must be ejected from anodes and go to cathodes in discharge tube. Now obviously we know that electron negatively charged is actually get ejected from cathode surface and go towards positively charged anode. Okay? And from anode, some positively charged particle also get ejected and go towards cathode in discharge tube experiment. Then what was procedure of experiment? The procedure of experiment was electrical discharge experiment, in which perforated disc cathode was used in place of disc cathode, and gas pressure was not too low. Through cathode ray holes emerge on the anode opposite. Means in this discharge tube experiment, we actually learned that the high voltage electricity was applied, and the gases the gases had a low pressure. But in this case, the gases are not much in low pressure. Its pressure is not much low, and the cathode which are used are perforated disc. Okay, in place of full complete disc. Perforated disc, there are some holes are there, okay, through which any rays could so any rays of anode ray can pass through. Okay, and then what is canal ray or anode ray? So I hope you understand the difference between the discharge tube experiment. From that electron were discovered, and difference between this design, because both the discharge tube experiment and this design differs, because the gas which is there in this tube, okay, to study about the protons, the gases are not much in lower pressure other than discharge tube experiment, and the cathode which are used, obviously it is negative in charge, but it is perforated disc, not a full complete disc. It is a perforated disc, so that positive charge from anode, okay, get passed through this cathode. Now, what is canal ray or anode ray? Ray pass through cathode holes, travel in streams. Travels in streams or canal form. Produce a glass glow on the discharge tube other end. This ray is known as canal ray or anode rays. Now, whenever ray pass through these cathode holes, okay, these rays are actually in the streams forms or canal form, and when this rays which is emitted from anode when passed through the cathode holes, this form a glow, okay, on the opposite side of discharge tube, and um, um, this glow is called canal ray or anode rays. See, in this experiment, okay, this is same as discharge tube experiment, but the pressure of pressure of gas in these tubes is not much lower than which was applied to discover electrons or to study the cathode rays, okay, and perforated cathodes is being used. So high voltage electricity is supplied from anodes. Positive charge electrode travels in stream form or canal forms. It passes through cathode and then strike on this tube which is opposite to the anode, and it gives a glow, and this glow is called canal rays or anode rays. In this discharge tube experiment, now what is anode ray or canal ray? Now, anode ray have positively charged particle. These rays are known as positive rays. Anode ray of course contain particle which is positively charged, and also it is also known as positive rays. Now we will know about property of canal ray or anode rays much further. Now, ray travel in straight line opposite to the cathode rays. These rays, canal ray or anode ray, travel in straight line opposite to the cathode ray. Okay. What happen in presence of electrical field to the canal rays? In presence of electric fields, canal ray deflect towards negatively charged electrode. Indicate that positive charge particle consist in canal ray. Means what happened to anode ray in presence of electrical field? It's deflect towards negative electrode, which indicate that this anode ray contains positive charge. What happens when canal ray strike on zinc sulfide screen? When canal ray produce fluorescence when incident on zinc sulfide screen. If zinc sulfide screens are there, and when canal rays strike on these surfaces of zinc sulfide screen, fluorescence is produced. What happens in presence of magnetic field to the canal ray? This ray also affected by magnetic field and confirm the presence of positively charged particle. Means in presence of magnetic field also get proved the positive charge is present in anode rays. Okay. Then charge to mass ratio of particle depend on gas in the discharge tube. Now ratio of charge to the mass ratio of particle is depend on gas in the discharge tube. Means number of electrical charge to the mass ratio depend on amount of gas which is present in discharge tube. Means amount of discharge tube will determine what will be the amount of ratio charge to the mass ratio. Positively charged particle carry whole number, multiple fundamental unit of positive electrical charge. Positive charged particle carries whole number and positively electrical charge fundamental multiples. Into the next page. Discovery of proton. We are back again to the discovery of proton. That what is a proton? Obviously it contains positively charged. Positive mass determination revealed that mass of one particle was 1837 times the electrical mass. This particle was called proton. This particle protons is 1837 times more than 1837 times more than the mass of electrons. How the presence of proton is confirmed? How the presence of proton is confirmed? Proton presence is confirmed by radioactive disintegration. Wherever the radio disintegration will be there, protons existence is confirmed. Means proton exists due to radioactive disintegrations. How a particle ray produce? Positive ray produce. How positive rays are positive ions are formed? When high-speed electron cathode rays strike molecule of gas in the discharge tube, it knocks one or more electron from it. Thus, positive ion is formed. Whenever electrons ejected from cathode, then strike on the gas molecule, and due to which gas dissociate and form positive ions in discharge tube. See, electrons strike with gas molecule form ions, then ions. What is chemical reaction for positive ion? This is the chemical reaction. M plus N electrons gives Mn plus N plus 1 electron. Positive ion pass through perforated cathode and appear as positive rays when electric discharge is passed through gas under high electric potential. When positive ions is passed through perforated cathode, appear positive ray when electrical discharge pass through gas under high electric pressure. Obviously, we already learned that this positive ray pass through anode at which high electric potential is applied. Then molecule dissociate into positive atoms ion that constitute positive rays. Molecule then, obviously this molecule in this reaction we know that molecule dissociate into positive ions, that constitute positive rays. Now what E. Goldstein discovered in discharge tube containing hydrogen gas? He discovered proton in discharge tube containing hydrogen gas. Means how he discovered? He discovered when a hydrogen gas was filled in discharge tube experiment, and he had discovered proton. Next to the next page. Now see, hydrogens, it dissociated 2H plus 2 electron, and by this positive ion presence is existed. What suggests of the study about proton nature? Proton actual mass is 1.67 to 10⁻24 gram. Proton mass is 1.0727 AMUs, where atomic mass unit proton electrical charge is equal in magnitude but opposite in sign, that of electron. Proton charge 1.60 10⁻19 coulomb, elementary plus 1 unit. charge unit of proton. Ernest Rutherford in 1919 gave proof of the presence of proton in the nucleus. How did Ernest Rutherford prove the presence of proton in the nucleus? He bombarded atom of nitrogen and aluminum by alpha particle and proton rejected. Means what Ernest Rutherford did to prove the existence of proton, he bombarded alpha particle to the nitrogen and aluminum atoms, okay, and protons was ejected. Neutrons are unstable outside the nucleus and disintegrate into protons and electrons. Neutrons are unstable outside the nucleus and disintegrate into protons and neutrons. Protons were obtained in a variety of nuclear charge, confirming further that all atoms contain protons. Protons are obtained from nuclear charge variety and confirm further that all atoms contain proton. Means by variety of nuclear reactions, proton existence was confirmed. Proton is defined as subatomic particle which has 1.00727 EMU mass and plus 1 elementary unit. The subatomic particle is 1.0727 EMU mass plus 1 unit. It has 1 unit mass number and 1 unit positive charge. So we can say that note that protons existence can be confirmed by only nuclear reactions or radioactive disintegration. So if one want to confirm the presence of protons, so through nuclear reactions or by radioactive disintegrations, proton existence can be confirmed. And let's turn to the next page. Now we will learn this discovery of neutron and constituent atomic nucleus on next lecture.